Hello everyone, welcome to my channel. In this video, I want to explain the verifications of loss of resistance. Verification of loss of resistance experimentally. Now, already I told the resistance depends upon the factors nature of the material, second one temperature, third one length of the conductor, fourth one CSA cross-sectional area of the conductor. On these factors the resistance of the conductor depends. I explained in the last video. But now in this class we have to prove practically. So to prove these factors practically, we should do some experimental setup. That setup is first some wood piece, that means plywood piece, some wood piece you should take and fix two iron screws on the surface of this wood block at certain distance. The distance between these two screws is approximately 10 cm. The distance is not important, but 10 cm distance apart you should fix two screws on the wood block. Fix two screws, ordinary screws are there, no? That screws with screwdriver you fix at a certain distance. The distance is not exactly 10 cm, that is your wish. Suppose, okay, now I kept 10 centimeter distance on this wood block. Now this is ready. This is only useful to verify all these factors. First you set up like this, then you should take some wires, that is conductors, some conductors. See, 10 centimeters of all with same cross sectional area, 10 cm length, same cross sectional area of copper wire, aluminum wire, iron wire. Three types of materials, one copper wire, one aluminum wire, one Fe means iron wire you take. These wires are, that means conductors are having same length 10 centimeters and same thickness, that is cross sectional area is same thickness, means the cross sectional area should be same. Like that you take three different materials wires. In this case copper, aluminum, iron I took. Your wish, any materials you are having means you can take. Now the first, next this is the wood block, then the connection should be, here also we want ammeter. To measure the current flowing through these conductors, we want to connect an ammeter in series. So this is 4 batteries I took, 1, 2, 3, 4, 6 volts. Suppose 6 volts battery. That means 1.5 volts cells, 4 cells you arrange. Then that is 6 volts. Now arrange like this. Two screws. One end of the screw connected to one terminal of the ammeter, the other terminal of the ammeter connected to positive terminal of the battery, the negative terminal of the battery directly connected to other end of the screw. Now this is open. Now here switch, for every circuit switch should be there. Okay. Now if you switch on, what will happen? The current will flow through this. Here it will stop. See, here there is no contact between these two screws, that's why no current will flow, simply. Okay, when you switch on also no current will flow because these two ends are open. This is open circuit. Now to verify first property, nature of the material. Now see, first you take this centimeters wire, that means this distance is centimeters, no, that's why minimum centimeters. Some long also you can take. Now take this copper wire and touch the two ends of the copper wire to the two ends of the screws. Here one end touch the screw, one end touch the screw. When you are touching the screw and you switch on, what will happen? Current will flow through this conductor. The current will flow through this conductor. That flowing current, how much current is flowing through this conductor, the ammeter will show. You note down that CU. In the case of CU, note down that reading. Suppose I1 milliamperes. I1 milliamperes. Note down the current. Okay. Next you remove this one. You switch off and remove this one. Next take aluminum conductor. You see, this is important. Same length, same cross sectional area. All are. Now second, aluminum, that wire or conductor you place. That means touch the two ends of the aluminum conductor to the two ends of the screw. Now again switch on. Now measure the current flowing through this ammeter. Now aluminum, that is I2, second case I2. You note down the current as milliamperes. It will show some milliamperes of current. Now again you remove this and third time Fe, iron wire you take and touch the, as usual, touch the two ends of the iron conductor to the two ends of the screws. Then switch on and again take the reading of ammeter. That means current flowing through this iron conductor. Now you take it as I3 milliamperes. So now if you observe these three values, I1, I2, I3, these three are showing different readings. These three are different readings. No two readings are equal. That means here what is current? I by R. Here we are not changing the voltage. I is V by R. So I is equal to V by R. We are not changing this one, but this is changing. Because of which it will change? The value same means because of changing in this resistance. That's why in the three cases, what is changed? R is changed. What is R? See, in the first case it is the resistance of copper, second case it is the resistance of aluminum, third case it is the resistance of Fe. That's why the resistance changes. Even though the length and cross sectional area of the material is same, also the resistance is changed. That means length not changed, cross sectional area not changed. See, length not changed, cross sectional area not changed, temperature also not changed. At the room temperature only we are doing this experiment. Now which is changed? Material changed. That means material change. Material means it is having some nature. One material having one nature. So that's why by this experiment we can confirm the resistance of a material is depends upon the nature of the material. So for every experiment the setup will not change. So that's why. Now temperature. To prove the resistance depends upon temperature. Now same setup. First iron wire you take or any wire you take. Suppose iron wire you take, Fe wire. Okay, I touched these two ends. Then switch on. I saw the reading. That is first case I1. Some first case, that is what Fe. Now I1. I took the reading of the ammeter. I noted. Now same this iron wire. Now with the help of tongs you catch with the help of tongs and you heat the iron conductor, that wire, red heat on by electric stove or any gas stove, anything. You heat it, strongly heat it. That means you should increase the temperature more. Very strongly you heat it. You should increase the temperature more. Now you touch on heating, you touch the two ends of that conductor, same cross sectional area, same length and same material also. Now you touch the two ends. Now note down the reading, switch on and note down the reading of ammeter. In the second case temperature change, second case the reading you note down I2. Now also you will observe the two I1 and I2 are different. Why different change? Cross sectional area not changed, length not changed, even material also not changed, but this is changed. Voltage anyway not changing, but it is changed. That means I is equal to V by R. If R change only, the I will change. R changed. But these nature not changed, length not changed, CSA not changed. What changed? Temperature changed. Before ordinary temperature we kept that iron wire, but we heated. We heated means what? We increased the temperature. So because of the increase in temperature, the resistance changed. So practically proved. When temperature changes, the resistance changes. That means it depends upon the temperature. How it depends means, if temperature changed, in this case I2 less than I1. I1 is more. That means temperature increased, the current decreased. Why? Because this is because in the first law only. What is first law? Laws of resistance. The resistance directly proportional to length. Length increased means resistance increased, we know. Length increased means resistance increased more. We know the other property, all the metals will increase due to heating. That also we know in physics. If you are heating, if the temperature increases, the metals will expand, their length will expand. That's why due to heating, second case, the length of that wire expands. As long as the temperature is there, that expands that length. So length increased means what? Resistance increased. Resistance increased means what? Current decreased. So in the second case, current is I2, that is this relation, increased. Like this the readings will show. Anyway, we know the temperature depends upon the resistance, depends upon the temperature by this experiment. Now third one, length of the conductor. Now any material you take, suppose copper I am taking, copper wire. First case 10 cm copper wire I am taking and placing, touch the two ends of the copper wire to the two ends of the screws and switch on. I measured the current I1. I measured the current amperes by seeing this ammeter. I noted this current, first case. Now in the second case, I took 50 centimeters of copper wire, same diameter. Cross sectional area I not changed, same thickness of wire, but length only I changed. Material also copper only. So this length wire I touched. Because this is length, we can bend. See, we can bend while touching. Because this distance is only 10, this is 50, automatically it will bend. It bend also, current will pass, no problem. How many bends also there also, current will pass through bends. So that's why current passed and you switch on. Note down the current. In the second case, when the length is 50 centimeters, that is I2. Now if you observe, these two values also vary. Changes are there. Why changes? Here see, cross sectional area not changed, material not changed, temperature not changed. What changed? Only length changed. So because of length only, V by R, V not changed. V not changed also, this is changing means depending upon this, the resistance changed. Why resistance changed? Here CSA not changed, temperature not changed, nature not changed, same material, but length changed. So due to the length only it changed. That means the resistance value depends upon the length of the conductor. Like that we can prove. Next and last, cross sectional area. Okay, cross sectional area. In this, you take suppose aluminum wire, cross sectional area, same length, 10 centimeters length, aluminum wire only take, one thin wire, thick wire, very large diameter, thick wire, two wires you take. First thin wire, first case thin wire you take. Now you touch the two ends, same length, touch the two ends with that conductor, switch on, current will flow through the circuit. Now conductor flows through the circuit means here conductor. Take the reading, ammeter reading, that is I1. Next you remove this, then you connect the same length of aluminum, same material aluminum wire, but different thickness, that means different cross sectional area, then switch on, current will pass through the conductor. Now take that reading as I2. In this case also changes will occur. So Why? You know, again V by R. Because of this change only this will change. This is not changing means because of this only this will change. R changed. Why R changed? Length not changed. Temperature not changed. Nature not changed. Nature means same aluminum only you took. That means nature not changed. Temperature same temperature only. Length also same length only. What changed? Thick wire, thin wire. That means cross sectional area changed. Because of that cross sectional area, the resistance changed. Resistance changed only, the current changed. This change in current indicates the change in resistance. So, by this we can confirm the resistance of a conductor depends upon the cross sectional area of the conductor also. In this case, how it differ means, suppose first case, second case. The area is, first case is thin, second case is thick. What I told, the area is inversely proportional. The resistance is inversely proportional. In the thick means this is more resistance. Thin means it is less. Less means less resistance means more current. So I2 more than I1. Because in the second case the cross section area increased. Cross section area increased means according to laws the resistance depends inversely proportional to cross sectional area. That means cross sectional area increased means resistance decreased. Resistance decreased means current increased. So second case current is I2. So I2 greater than I1. Like this the reading will show. Okay. Like this the resistance depends upon all these factors. Now one more topic. Based on the current and resistance, materials are categorized into three types or groups. One, conductors, insulators. Third one is semiconductors. See, according to current and resistance, the materials are categorized into conductors, insulators, semiconductors. First, I will tell with respect to current. See, conductors are the materials which allows the free flow of current. Conductors are the materials which allows the free flow of current. If current freely flow, those are called conductors. Generally, conductors are metals. Current I am telling. Next, insulators. Insulators are the materials which does not allow the flow of current. Insulators are the materials which does not allow the flow of current. Current it does not allow, current will not flow. Those are called insulators. Insulators are some examples: bakelite material, rubber, wood, plastic, paper, mica. So like that some insulators are there. So those are insulators. Insulators means simple, in simple way current will not flow through them. The next, semiconductors. Semiconductors are the materials which partially allow the flow of current. These are not stop the current fully or not allow the current fully. Partially they will allow. Sometimes differently it will vary. Those are called semiconductors. The example for semiconductors are mostly two are there: germanium and silicon. These two are the materials belongs to semiconductor. Depending upon this, total one subject is there, that is electronics. The modern electronic subject is depends upon these two. That means semiconductors only. Semiconductors. Before inventing the semiconductors, the science and technology is different. After the invention of semiconductors, the technology is different. When invented these two materials, totally there is a lot of change in technology, modern technology. That even the robotics, the basics for the robotics also, the materials germanium and silicon I will tell, because they are also depending upon some that microprocessors like that. The microprocessors also prepared, that circuit chips also prepared with so many large number of semiconductors are there inside that microprocessor. That is also circuit depends upon the semiconductors only. So that's why these are the two are semiconductors. Germanium, examples germanium, silicon. Now based on resistance I will tell. These three only. Based on resistance I will Tell the definitions. Now, what are conductors? Conductors are the materials which are having very low resistance. Conductors are the materials which are having very low resistance. Low resistance means current will pass. That's why conductors. Now, insulators. Insulators are the materials which are having a very large value of resistance. So, insulators are the materials which are having a large resistance. Very large resistance means current will not flow. That's why they are insulators. In terms of resistance, we are telling semiconductors. Semiconductors are the materials which are having partial resistance. Partial resistance. Some resistance they will show. Mediator, intermediate to these values, the resistance they will show. That's why current also intermediately will flow. So, like this, those are the materials depends upon the current and resistance. I hope everyone understood this lesson. If you like this video, please subscribe my channel. Thank you. Thank you for visiting this video.